So please welcome Jess Archer.
Hello, everybody. It is fantastic to be back in Amsterdam again. I'm Jess Archer. I'm the engineering team lead for the Australia Pacific team, where there's 6 of us, so 5 incredibly talented people and myself, and we've been working on Laravel Nightwatch. So for those that haven't heard, Laravel Nightwatch is an observability tool specifically designed for your Laravel applications. It does error tracking, traces, metrics, and logging. So today I'm going to give you a little bit of a kind of a recap tour for those that haven't seen it. We're going to show off some new features we've been working on, and then we're going to show how to set it up in your own applications. We're then going to do a little bit of a case study about what we learned from having Nightwatch installed on Laravel Forge. So let's jump straight into the demo. Alrighty, so we've got our login screen here. So I'm going to log in. And now we've landed on the dashboard. So this is Nightwatch dashboard. This kind of gives us this top-level overview of our application and all the things that are going on. We're going to breeze through this fairly quickly. I'm doing demos at the booth upstairs, so you can come and see me for more details on this. But we've got information about the requests in your system, both successful, unsuccessful, and durations of those requests. We've got some cards that kind of show you some top-level stats about your application, exceptions, some slow routes, information about your jobs. And we've got information about your servers, so CPU, memory usage, and disk space usage. And if any of those servers stop reporting, like we can see LARACONeu here has stopped reporting, you'll see those as well. Some information about the users in your system, those impacted by exceptions, the most active users, the number of authenticated users over time, and authenticated versus guest requests. So at any point on this dashboard, we can also switch between different time periods. So we can go anywhere from the last hour all the way up to the last 30 days. And also, we can have multiple applications and monitoring with Nightwatch. So up here, we've got an application switcher, where we can have multiple organizations with multiple applications, and each application can have its own environments that are being monitored. Nightwatch is designed for production, but you can use it on your staging environments. You could probably even use it on your local environment, although I don't know why you would. All right, so let's jump over now to the requests, the activity section, and we'll jump into the requests screen. So with Laravel, requests are kind of the most important thing about our applications generally, so we'll kind of talk about that the most. I'm going to go to the 7-day view because I think the graph is prettier. So at the top here, we've got a graph here that's showing you the number of successful requests and then the number of 400 and 500 errors. We kind of don't use green to show success a lot of the time because we want to bring your attention to the problems in your system. So this kind of gives us this overview of all of the traffic through our application. We can kind of see there's been some error spikes here, and then a general distribution of errors and 400 errors over time. And then we have information about the overall duration or performance of your application. So we're showing the average duration of requests and also the P95. So the P95 is the 95th percentile. It basically kind of ignores the top 5% of those extreme outliers and kind of shows you what generally is kind of the worst experience for most users. Below this, we then have a list of all of the routes in your application. So we can kind of break things down, and for each route, we can see the number of successful requests, 400s, 500s, the total number of requests, and then also their individual averages and P95s. So we can identify problems via the graph. We can scroll down through the table here. We can kind of sort by 400s, 500s, totals, averages, P95s, all that good stuff. So let's go. I want to kind of dive into this now. So let's say we've identified that there's a problem here with this destinations route. This one's a pretty good one. So we'll click on this route, and now this gives us kind of this zoomed-in view just about this route. So now the traffic here we can kind of see is just from this route, same with the duration. So it kind of gets a little bit less muddy when we zoom into a specific route. We're kind of comparing apples with apples. So in this case, we've got a route that has some performance issues and it has some errors. So if we're trying to diagnose either performance or errors, we generally want to go to a specific example that represents the problem so we can find out what happened to cause it. So if we're trying to diagnose a performance issue, We could filter by requests over the average or even over the P95, and this will give us our slowest kind of requests. So we'll jump into an individual request to this route. And now we're looking at an individual request. So no longer looking at kind of aggregated data, we're now looking at a very specific request. We have some information at the top here, status codes, the duration, request size, response size, the peak memory usage, the server that processed the request, normally the deployment, I don't know why that one's missing there, and then some details about things that happen inside the request. So the number of queries. Here we can kind of see that this one's probably slow because of queries, because they make up the bulk of the time. We could click on this view button here and see a list of all of the queries that ran in this request. We've got the number of outgoing requests, queued jobs, storage reads and writes, cache events, hydrated models, mail, and notifications. We can also see if there was a user authenticated at the time. We get their details and the IP address that made the request. If we scroll down a little bit further, we can see a timeline of everything that happened inside this request. So this is a pretty straightforward one. We can kind of see here, this query here is taking up the bulk of the time. We can zoom in and out on this one. We can click on this query, get some information about it, and again, see this run on the MySQL connection. It originated in this destination controller. So this is probably our problem. But we can see here that we had a cache miss right before this query. So it seems like we've already tried to solve this problem with a cache, but every so often, an unlucky person will hit a cold cache, and then we'll have to run this slow query. We can see straight after the query, there's a cache write. And we can see here the TTL on that's 10 minutes. So every 10 minutes, one poor user is going to have to run this slow query. There's a few things we could do to solve this. We could try and improve the query. It would probably be the best place to start. But assuming that's as fast as it can possibly get, we could do things like use Laravel's cache flexible method to do stale while revalidate caching, where it'll serve a stale value and trigger a refresh of it. Or we could even keep this cache warm via a queued job. So let's just confirm that this was what was making it slow. So I'm going to come back to the list, and let's go to an example of a fast request. And we can see here we had a cache hit, less than a millisecond, and this request in total was 29.48 milliseconds, nice and fast. All right, let's now come and have a look at these errors here. So there's a few things we can do here. These errors are all kind of clustered together. We could sort by 500s, and we'll kind of see all of the errors in here, and we're getting a preview of the exception message here. We can also use the graph here and just kind of zoom in on this area, and zoom in a little bit further. And so we're filtering by custom time periods based on the graph, and now we're looking at just this kind of spike of errors. So we've got some here that are slow in having errors and fast in having errors, which is kind of interesting. So if we go into the one that is slow and having errors, because there's been an unhandled exception, we promote that to the top of the page. So we can see our exception message up here in stack trace, undefined array key 98. Kind of weird. If we scroll down to the timeline, we can see that we're doing this query, the slow query, and then we're hitting this exception, this undefined array key 98. Now, we're getting the top 100 destinations, so my suspicion here is that sometimes the top 100 doesn't always return 100, and we're kind of hard-coded looking at all of the items in there. And I guess even when it's cached, the same problem still happens, because even on a cache hit event, we're still getting that same exception. All right, let's jump back out now to requests, and we'll just look, let's go back to our 7-day view. We can kind of see here we've got some requests here that have got quite a few that have different, that have a high number of exceptions. So if we wanted to see what was causing the problem during this time period, we could kind of just zoom into this. And now we can see that most of the exceptions in that time range was this, this GET request to this flight's ID endpoint. So that's probably what was contributing most of the problems there. There's another route in here I'd like to show you, because it's kind of the kitchen sink route, as I like to call it. So if we go to this post-flights endpoint, this one's got errors sometimes. It's pretty slow. Let's go to an example of a successful one. And let's scroll down to the timeline here, because there's a pretty more busy sort of timeline in here. So we'll kind of zoom out a little bit. And we can see that we're dispatching some jobs, so this process flight job and this flight offer mail that we're sending, or queuing rather. And we can see down the bottom here, all of the job attempts that were run as a result of this request are also shown in the same timeline. So we pass the trace ID all the way through to all of the jobs. And so we can see here, the job actually started its first attempt before the request had even finished. The first attempt, pretty quick, failed. second attempt failed, third attempt failed. So we can kind of see the total duration of how long that job spent running its attempts. And then the other flight offer one that ran here, kind of slow, sending mail, and completed down there. All right, so that's kind of what we have about requests. We can kind of zoom in and see tons of information starting from that very, very top level. We have the same sort of information for jobs. We don't have a ton of time to go through this in detail, but if we would go to one of these jobs that seems to have a lot of released and failed, so released is kind of the means they've been retried. We can come in here and see there's been a ton of ones that try attempt number 2, 3, and failed. So we show all of the individual attempts in here. In this case, it seems like there's some different errors that are happening between these attempts. We can click on any of these attempts, and we'll see, in this case, there was an unhandled exception, so that's kind of promoted to the top of the screen again. If we scroll down, we can see the current attempt we're looking at, as well as all of the other attempts of this job. And we can also still see the request where this particular job was dispatched from. So we can expand this out and kind of follow it back to its origin. We can also see if there was any other jobs that were sent on that request. They're also still included here as well. We can also switch up here between any other attempts from the same kind of attempt to run this job. So we can kind of switch between all of those. And I think in this case, we did have some different errors between those attempts. We have the same sort of information for commands, for scheduled tasks. So we'll kind of skip over those, and we'll quickly touch on exceptions. So when you look at things from the request view, generally users are interacting with requests most of the time. So that's generally where you want to kind of start. That's where those problems are going to happen. But if you've got a lot of 500 errors, they could be caused by a ton of different exceptions. So it's not always easy to kind of see the breakdown of what types of exceptions are happening. So it's nice to be able to kind of zoom into exceptions on their own. Everything at the top of this list here is I kind of think of them as these like execution containers. They're entry points into the application. They're not slow by themselves. They're slow because of things that happen inside, or they have errors because of things that happen inside. So down the bottom here are those things that happen inside that can be slow and cause errors. So here we've got our list of all of our exceptions. An interesting thing we can do in here is also filter by handled exceptions. So these might be exceptions that we've kind of handled gracefully, but they're returning 200 status codes. So again, you wouldn't see those through the request view, but you can still come in here and see those as long as you're reporting those. For any exception, we can click on the exception, get stack trace information, and we can see all of the occurrences of this exception, the user that was impacted by it, and we can see the source of the exception. So we can jump to, in this case, the request, where this exception was triggered. In this case, there were some logs associated with this request, so these are bundled in here as well. And in our timeline here, we can kind of see exactly where that exception happened, and there was an outgoing request beforehand that had a response code. The flight has already been deleted. We also have information about database queries. Again, this is something that you'll generally see slow queries because of slow requests, but there's extra things we can see through here. So if we were to look at our total tab here, we can filter by the total time spent running queries over the time period. So if I go to 30 days here, we can see how long was spent running each of these queries. This one, the second one here, is kind of interesting. It spent 31 minutes in the database. The query itself is not particularly slow, so it probably wouldn't have triggered a slow request. But because we run this one so many times, if we were able to even halve the time of this query, then that would make up some considerable savings. There's one more in here I wanted to show you. If I sort by the number of calls or the number of times this query has been run, there's this query here, select from tickets. I'm going to jump into this one, and just to quickly show you, go into a request where this query has come from, and just see an example of what an n+1 looks like in Nightwatch. So again, this is a very fast query, but because it runs so many times, it ends up kind of extending the time of that request. All right, so we've got things like notifications, mail, cache events, outgoing requests. We don't really have enough time to kind of touch on all of those, so let's move on to logs very quickly. So you can set up Nightwatch as your log driver, and all of your logs will be sent through to Nightwatch. The benefit of this, of having your logs in the same place, is, as we saw on that previous screen, if there was any logs associated with a request or a job attempt or a command, they'll all be shown when you drill into that specific request, but we can also look here at logs kind of in isolation. We can filter to specific types, so if we would look for critical and emergencies. If you attach any context to your logs, those will be kind of, you can expand these and see the context. And from this screen, you can also jump to where this log came from. So in this case, we can go to the request where it came from. We can see this log here, as well as some other logs that were in this same request. We then have our monitoring section. So we have a page about all of the users of your application. So here we can kind of see the users making the most requests, having the worst time with 400s and 500s, the number of queued jobs they're kind of responsible for triggering, the number of exceptions, and their last seen time. For any of these users, we can dive in a little bit further and kind of see a summary of this user, their top routes that they've been hitting, the slowest routes they've been experiencing, and the top queued jobs that they're kind of responsible for. We can see their specific activity over time, and then we can see the individual requests they've been making, so we can kind of follow their path through the system. We then have a page for servers, so this is kind of similar to what we saw on the dashboard, where we have an overview of our servers, and then we also have our deployment screen. So you can tell Nightwatch about your deployments, and then we can kind of attach those to requests, and then you can start to see whether there's a particular deployment that might be responsible for a problem. All right, let's jump over to a new feature that we haven't demonstrated yet, and that is our issues. So Nightwatch can automatically create issues for you and notify you when there are problems. So I'm going to jump over to our open issues here. And we've got a couple that Nightwatch has created for us here. So anytime there's a new exception, Nightwatch will create an issue about that exception and send you a notification. Anytime there is a slow job, so a job that's over your configured threshold, slow requests, servers over memory that running out of hard drive space, all those sorts of things. So for any given issue, we can kind of see when it was first seen, when it was last seen. We can assign it to users. So let's jump into this undefined array key 97. We kind of saw this one earlier. For an issue, we can give the issue a description. We can change its status. We can set its priority from no priority, low, medium, and high. And then we can also assign this to someone. We can see an example of the exception here. So this is like a recent example of this exception happening. And then we can also see a list of recent occurrences. So again, we can jump to the request where this came from and really try and quickly track this down. We've then also got an activity log at the bottom of the page here where we can see the history of this issue and of this exception. So we can see when Nightwatch created it. We can see I've updated the description, I've updated the priority, self-assigned the issue, and I've also added a comment with code blocks in here with what I think the problem is. So this is where we're kind of iterating from 0 to 100, expecting there will always be 100 in this array, and I've got a proposed solution in here. So let's pretend we've resolved this one, so we can mark it as resolved, and we'll go back to our open list. Let's just jump into one of a slow routes one. So our destination route over here that we were looking at earlier. So this is a performance issue instead. So this one kind of shows you, again, recent occurrences of requests that kind of were over the threshold. So again, we can quickly jump into an example of the request and see our slow query here. But we can also write notes about it again and assign it to other people and kind of see the history of this over time. Now, if we mark an issue as resolved, if it occurs again, Nightwatch will automatically reopen it for you. We can also mute an issue. If you have an issue that you don't want to fix, you can also mark it as muted. So we can also jump over here and see our unassigned issues. So this is kind of our triage area where we can see all the issues we haven't kind of assigned to anyone and all those sorts of things. We can then filter to only looking at our own issues, and we can see our resolved issues, and also if we have any muted issues, which we don't have. So we talked a little bit about thresholds, so I'm just going to quickly jump over to our settings page, where this is where we can configure the thresholds for the specific application. So we can set a default threshold for all of the routes in our system, so by default I've set it to 1 second here, and then you can set some overrides on a route-by-route basis. So we can kind of set a higher threshold if we want here, or also a lower threshold if it's maybe like a mission-critical route. We can do the same things for jobs, commands, scheduled tasks as well. So all of those kind of entry points into your system. At the moment, we don't have them specifically for queries because you'll end up getting 2 alerts. Then you'll get an alert about a slow request and an alert about a slow query. All right, so let's go back now, and let's talk about installing this in a brand new application. So I have this application here called WeatherWatch. So this is a weather application, just a very basic Laravel application that we've created. Doesn't have Nightwatch installed at the moment. So let's go ahead and look at how we'll set that up. So I'll switch back over to Nightwatch, and I come up to our application selector and go to New Application. So I'm going to give this application a name. It is WeatherWatch, and an environment name. So by default, production, but we can change that. So we'll go with that one. And then it's asking us to install the agent. So I'm just going to follow these instructions. We're going to compose a require. So let me come over to my terminal, and we'll run this one. Hopefully it doesn't take too long. It's gone all quiet now. Alrighty, there we go. So let's switch back over now to Nightwatch and find out what we need to do next. Okay, so we need to configure our environment. So we need to add the token to our environment variables. In this case, I'm going to put it in my env file. So let's just go env, go down to the bottom, paste it in there. Let's come back over now to Nightwatch, and we'll press next. All right, so now it wants us to set up the agent. So we're going to run php artisan Nightwatch agent. And we can see here the connection is listening. So it's listening for us to start up the agent. So we'll switch back to the terminal. We'll run this one. We can see the agent is initiated and is now authenticated. If we switch back over to Nightwatch, we can see it's already established that connection to Nightwatch, so we know that it's ready. We'll press complete, and we're now over to our WeatherWatch dashboard in Nightwatch. So we can jump over to our requests screen, and we'll see we have no requests yet. So let's switch back over here, and we'll refresh this a couple of times, and then we'll switch back over to Nightwatch. It can take between 10, 15, 20 seconds for the data to get across into here. So there we go. That was pretty quick. So we can already see our requests in here. So 2 requests. We can jump into, so these are to the home route, so we can jump onto this route, and see all of the requests. Click on one of these requests. It's a pretty basic application, but we can see exactly what happened. So in our timeline here, we've got the breakdown, by the way, of all the different lifecycle stages. So in the request, we've got the bootstrap stage, the middleware stage, the action, so in this case a controller, the render stage, the after middleware stage, and terminating. So we can kind of see there's a couple of queries, auth-related ones, selecting from sessions. We've got a query here selecting from our weather table on our SQLite connection, very, very fast. And then our query at the end to update our session. All right, so that is how easy it is to install Nightwatch in your own application. Alrighty, so let's now talk a little bit about the agent and how it kind of works in your application. So we've got a little bit of a diagram here kind of representing all the kind of parts of Nightwatch. So on the left here, we've got your application. This is your existing application, potentially running on multiple web servers, generating traffic, running queue jobs, all that sort of stuff. So you'll install the agent on your application. The data will then be batched up within the agent and then sent over to our ingest infrastructure, where it gets processed through all the various pipes and whatnot, and then ends up in our database to be viewed in the dashboard. So let's drill a little bit more into the your application side of this. So on the left here, we've got a specific web server. It's running, it's got some web processors running. It's got queue workers. It might have schedulers, be running commands, all that sort of stuff. So all of these events are getting fired. And at the end of the request, after the response has been delivered to the user, they get sent over to the agent, which is running locally on that server. So it's super, super fast. It doesn't really impact much on your web workers or anything like that. So that all of that data kind of gets sent over to the Nightwatch agent process, and this kind of batches these up and then sends them up to us. So it waits 10 seconds or 8 megabytes, whichever comes first. So the data should always be in the dashboard nice and quick. And once it's kind of reached that amount of data, it gets gzipped and then sent over to our infrastructure. We've done a lot of work to make this data collection side of things as low impact as possible. Performance monitoring will always have a very small impact on your system. It's kind of not possible to observe something without impacting it in a little way. But we've kind of had to write some pretty gnarly code. We don't get to use nice things like collections, all this sort of stuff. We just kind of use as low level and kind of memory sensitive ways of doing things to reduce the impact on your application. All right, so now let's talk a little bit about what we learned from having Nightwatch on Laravel Forge. So Forge is our server kind of management tool for Laravel. It's kind of a huge part of the backstory of Laravel and the reason Laravel is so successful, the reason we're all here today. It's also a big part of the backstory of Nightwatch. So Nightwatch has kind of evolved from Laravel Pulse, which we launched a few years ago. And we created Pulse because we had these needs to see things on Forge. And we created Pulse kind of working. So Pulse is a self-hosted application monitoring tool. It works with your existing databases like PHP and MySQL, but there's some limitations when you use those sorts of databases. And so Nightwatch has kind of become, what could we do if we weren't kind of restricted, if we could use whatever tools we wanted to use? And so yeah, Forge kind of has been this thing that we've built these tools for. So we kind of build for what we want and what we've needed, and then get more feedback from everyone here. All right, so we installed Nightwatch on Forge about 2 months ago, and in that time, we have collected 2,761,000,000 events from Forge. So Forge is far more active than I think any of us kind of expected. Tons and tons of traffic in there, and thankfully Nightwatch has handled this really, really well. So let's kind of break this down and look at some of the stuff we learned and what kind of has gone into this number. So just some quick kind of stats here. So the number of emails we have sent from Forge. So this is now looking at just the last 30 days, so not the full 2 months where we've had Nightwatch on there. So in the last 30 days, we've sent 256,000 emails. We've done 1.5 billion database queries, which just blows my mind. 78,000 exceptions. A little bit unfortunate. When I was first preparing this talk, it was about 700 exceptions, but we had a couple of little blips lately, which we'll talk about a little bit later. 245 million cache events with a 90% hit rate. 2.4 million outgoing requests. So Forge makes a lot of outgoing requests to various Git providers, the main one being GitHub, so 647,000 outgoing requests to GitHub. And we connect to 290 different hosts. So you can set up your own custom GitLab instances that Forge can integrate with. So we connect to a whole bunch of different host names, but mostly GitHub, GitLab, and Bitbucket. So let's now talk specifically about requests. This is kind of, I find, the most interesting part of Nightwatch. So for requests into Forge, in the last 30 days, we've had 119 million requests. We have, for our 500 responses, 25,500 responses, unfortunately, which we'll talk about. 218 of our routes are API routes. We've got 560 active routes out of 726 total routes, so quite a lot of routes that we're not using at the moment. We've got 357,000 unmatched requests. So these are requests where there was no route. So it's not like a 404 on a model, there was no route found. These are generally bots trying to scrape for WP login and all those sorts of things. Our fastest request is 8.14 milliseconds, and our loneliest route that had only one request in the last 30 days was the API endpoint to install Horizon. Now, we have a separate route to install Horizon via the UI that is very popular, over 1,000 requests to that, but I guess not many people know you can also install Horizon via our API. So now I want to talk about a couple of interesting charts first. So we've got this kind of chart here to our auth route where people log in, and we had a couple of events recently. So on the left here, we've got this massive spike in post requests to our login endpoint, 324,000. Now these kind of look like they're successful. They were 200, or in the 100, 200, 300 range, but that's because by default, Laravel returns a 302 response with the error that the password was incorrect when we're using inertia. So we kind of noticed this. We were trying to figure out what we were going to do about it. It happened again a little bit later, a bit smaller this time, and we then implemented rate limiting. So the next time this happened, those were 429 requests and didn't even kind of get to the point of hitting our database and trying to query whether there was a user. Next up, we've got our 500 errors for all over our app. So again, this was normally very, very small, but we've had kind of two issues lately that are kind of interesting to talk about. So the first one here, this little spike here, this one was an error that I honestly don't know how. It's the kind of thing that is hard to even write a test for. So we sometimes cache objects using Laravel's cache, and you can cache an object that has a class attached to it. Now we updated a package that happened to remove that class. So when we were hydrating from the cache, it could no longer find that class any longer. So it's the kind of thing that the new version of the code works fine because you cache whatever the new object is and it'll deserialize it. But if you've got existing data that doesn't know what that object is anymore, then you can kind of run into trouble there. We fixed this one within about 5 minutes. So this kind of spike in the bucket we're looking at here was a huge spike, but we kind of solved this very, very quickly by rolling it back and sorting that all out. The next spike was a kind of issue with the database query. So we had this very, very expensive query that we run. Now, we run this query. We were running it using the defer feature of Laravel, so it runs after the response has been delivered to the user. So it wasn't really impacting users at all. But it kind of got to this point where we were running so many of them, it does deletes and updates, and we ran into a database locking situation and ended up locking the entire database. Again, we solved it very, very quickly. It was very handy in Nightwatch to be able to see what was happening, jump in, and again, quickly solve that. Then there's this route. This was a pretty interesting route. So this is the webhook route to deploy an application with Forge. So this is where you'll send a request to this endpoint with a token, and it'll deploy your application for you. And we were getting a lot, like 48 million requests. So of the 115 million requests to Forge, 48 million of them were 404 requests on this one route. And we can kind of see it like stepped up over time. A lot of, I guess, automations trying to deploy routes with invalid tokens, and there's no human there, so it's just error, retry, and so on. So we solved this one, again, with rate limiting. We had some rate limiting on there, but it was kind of divided by organizations and all these different things, so we kind of tightened up those rules. And James did some really interesting things on that, where we need the rate limiting logic to live in Laravel, but once the rate limit is triggered, there's a header that Cloudflare receives. So once the rate limit has been active, Cloudflare can then enforce the rate limit, which is pretty cool. Then last up, we have this route here. This was the route that was responsible for that query that caused the lock. It's the kind of query that for some applications is fast, for some is slow. So it was kind of very jaggedy, but then it kind of reached that peak where all of the queries kind of started locking with each other. But then you can see we very, very quickly resolved it, and we were happy. All right, so now let's talk about a few of our most popular routes. So our most popular route, other than that 404 route, is the post to the broadcasting auth endpoint. So this is a Laravel endpoint for authenticating with WebSockets. We use WebSockets a lot in Forge, and the reason this number is so high is because as you navigate around Forge, if you click on a server, we have to authenticate to the private channel for that server. If you then click on a site, we then authenticate to the private channel for that site. So as you navigate around Forge, you're constantly kind of authenticating to different private channels. So very, very popular endpoint for us. We then have an API route to retrieve the list of sites for a particular customer. So this one's pretty popular, I guess, for people's all sorts of different automations. Forge has a very, very detailed API you can do all sorts of cool stuff with. We then have this route here. This one lists certificates for a given site. Again, quite a lot of requests to this one. I think James was saying that it's only a handful of customers responsible for all of these requests with various automations. And then we have the API endpoint to retrieve the deploy, sorry, not API, and the route to receive the logs from a deploy. So this is one that we continually poll while you're deploying if you're viewing the dashboard of Forge. So again, this one's quite high because we continue polling it to find new logs from a particular deploy. We've then got some problem routes to talk about here. So kind of our slowest route we have here is the Nova API search route. We can see here that on average it takes 8.84 seconds to search with Nova on Forge. And that's because by default, Nova uses a like query to search all of the tables. And we have some huge tables with tons of data, so it's pretty inefficient to use a like query. Now, Nova lets you use Scout to make this much, much faster. But you can see there's only 14 requests, and these are all requests by staff. So this one's probably not one we're going to focus on too much until we've kind of solved other problems. So we then have this route here. This was the one. This is an API route to retrieve the logs from your server. There's not a huge amount we can do about this one. So it takes on average 4.84 seconds. But this one has to SSH into a server to retrieve its logs. So there's probably not a huge amount we can do here other than maybe caching it for a short amount of time if people are continually polling this one. This was that route we talked about earlier that was getting all of those requests to deploy applications with invalid tokens. So they had a ton of requests to that one, but I think we've kind of solved that one now. And then last of all, we've got the post endpoint for creating a server. So this one takes 4.78 seconds. We do a lot of stuff when we deploy a server. We kick off most of the behavior kind of happens inside jobs, but there's a little bit of work we do up front in the request. So we generate SSH keys to connect to servers, all that sort of stuff there. We can probably move some of that to jobs to make that even faster, but then you've kind of got to deal with like failure situations. If it fails to create that, you've kind of got to handle those things. And in this case, when you push the create button to create a server, I don't mind if that takes a little bit of time. I kind of almost expect that it takes a little bit of time to create a server. That's a pretty big thing. But yeah, definitely something we can look at. All right, let's talk quickly about jobs. So just some overview stats here. Forge uses jobs for a lot of things. There's not a huge amount of stuff to kind of problems in here. Most of the problems with Forge in our jobs are problems connecting to servers, so servers that have just gone offline or are unreachable. But we've, in the last 30 days, had 7.7 million job attempts. Of those attempts, 7.6 million were processed successfully, 65,000 were retried, and 58,000 failed. Our most popular job is the process backup job, so 2 million jobs to run backups. These kind of run on a schedule to run backups for all of your Forge sites. 6,000 jobs to provision as app server. So I think there's about 9,000 servers created, but about 6,000 of those were app servers. 287,000 run artisan command. So this is when you can run an artisan command in Forge. This one had a couple of errors which were interesting, and I drilled into the errors, and there were a lot of model not found for our command model. What I suspect is going on here is people run a command and then go, oh, I didn't mean to run that command, and very quickly delete it before the job kicks off. And then 1.5 million jobs to deploy sites in the last 30 days. All right, that's everything I have for you today. So some important dates. We're going to be starting early access starting next week. We're sending out an email with a survey to everyone on the waiting list. So make sure you're on the waiting list at nightwatch.laravel.com. We're going to start off a little bit slow and then ramp up as we kind of get more confident with the system. And then we're going to be planning on opening general access in May. So make sure you're on the waiting list at nightwatch.laravel.com. Thank you.
You know what's coming? I got questions.
Lay them on me.
Forge is massive, man.
Forge is huge.
Dang.
And it just keeps getting bigger. Like,
does it scale?
it scales.
Okay. Don't worry. So, 2 quick questions. First question is from Bram. He's asking, is Pulse still going to receive updates?
Yes, yeah, we'll keep updating Pulse. Pulse is definitely still very much alive and well. Pulse is kind of frustrating working with the limitations of MySQL, but still a very, very useful tool. Great kind of first place to start with kind of observability. Nightwatch just kind of gives you this supercharged view where you can just drill into all of these things. But yeah, it'll still receive updates, all those sorts of things for sure.
Good, thank you. And Mario is asking, it's a tricky question. You know that you are in Europe, so what about GDPR?
Okay, sure. So we're planning on launching in quite a few different regions. So I think we're going to have a EU region, a US one, and an Australia-Pacific one, I think. Don't quote me exactly, but yeah, we're going to have all of the regions people need, and we'll roll out more regions over time. So hopefully that solves most of the GDPR stuff. We're going to be looking at things like SOC 2, all those sorts of things, full enterprise plans with all the stuff enterprise needs. So yeah, we're very much focused on having kind of like taking things to that next level with things like SOC 2, which we know a lot of people need.
Because we are Europe, we are worried about the bottle caps and GDPR.
The bottle caps?
Yeah, the bottle caps. They need to stick to the bottles. Did you notice?
No.
Take that bottle and you see. Not right now.
What's that got to do with GDPR?
Nothing, but you're in Europe.
Ah, yes.
Yeah. We are proud of it.
So we're also...
Yeah, but it works.
I've never received a round of applause for drinking water.
Bring that one to Australia and show it
They won't know
around.
what it is, even is.
We got spiders this big, but don't have the bottle caps like that.
Yes. So we also want to make sure our ingest infrastructure is in a bunch of different regions as well, not only for like data sovereignty, but also just to make sure that the requests from the agent running on your system to our infrastructure is as quick as possible. So yeah.
Thank you. So that'll be all. A big round of applause for Jess.